Okay, in this video I'm looking at how you can use the second derivative to identify the nature of stationary points. So we're used to using the stationary points to find, doing the first derivative to find stationary points on our function. So if we do that here, we get y dash is equal to 6x squared plus 12x. So then we can find when that's equal to 0. We can factorise that as 6x outside of x plus 2. So then we can say that 6x is equal to 0, so x is equal to 0, or x plus 2 is equal to 0, so x equals minus 2. We can then sub those coordinates back in to work out the, sub in the x value back in to work out the y. So if we've got the 0, we would have 0 cubed is 0 times 2 is 0, plus 0 minus 2, so we've got 12, so our coordinate would be 0, negative 12. If we sub in the 2, we're obviously going to get 2 cubed is 8, times 2 is 16, and then we've got 2 squared is 4, times 6 is 24, and, negative 2, so that would be a negative 16 there. Yes, it'll be a positive 24, and then we're taking away 12, so negative 16 plus 24 is going to be 8, take away 12 will be negative 4. So then our coordinate will be negative 2, negative 4 there. So that gives us our two coordinates that we're then wanting to investigate. So then when we do the second derivative, we will get 12x plus 12. So if we sub in the 0, we're going to get 12 lots of 0 plus 12. So we get a 12 there, and then we know that when we get a 12, that means that is going to be a minimum. And then over here, if we put in the negative 2, we're going to get 12 times negative 2 plus 12 gives us negative 24 plus 12, which is negative 12. So then that will be a maximum. So we can then use that to sketch that and show that it's a minimum and maximum on our sketch. So that's another thing that we can do with that, to look at stationary points and identify them as minimum or maximum, and then we can use that for our sketching.